Good day, students. Today we are going to take another example on sum to infinity of a GP problem. So the second term of an exponential sequence is 20. When you hear exponential sequence, it means geometric progression, geometric sequence. If the sum to infinity is 90, find the values of A, common ratio, B, the first term. Solution. We have that as the second term, which is T2, which is equal to AR equal to 20. And again, the sum to infinity is equal to 90. I know that sum to infinity, S infinity is equal to A over 1 minus R. This implies that 90 equal to A over 1 minus R. This also implies that by cross multiplication that A will be equal to 90 bracket 1 minus R. So this is equation 2, while this is equation 1. Now from 1, AR is equal to 20. Then substituting for A equals 90 bracket 1 minus R into 1. We have that 90 bracket 1 minus R multiplied by R is equal to 20. Can cancel 0 here. This implies that 9R bracket 1 minus R is equal to 2. So if you open the bracket, you are going to have that 9R minus 9R squared is equal to 20. So it's equal to 2, sorry. So you are arranging it minus 9R plus 9R minus 2 will be equal to 0. So when you have this, you're going to have that 9R squared minus 9R plus 2 is equal to 0. So what we are going to do here now is we find two numbers. So you have simple factorization. So can give you that 9R squared minus 6R minus 3R plus 2 equal to 0. That's by factorization. So we're going to have what is common here is 3. So this should be 3R bracket 3R minus 2 minus 1 bracket 3R minus 2 is equal to 0. So if you go further now, we're going to have that 3R minus 1 into 3R minus 2 is equal to 0. Therefore, R is equal to 1 over 3, or R is equal to 2 over 3. So for us to find the value of A, at the first term, remember the question says we should find the first term. So let's take for R1. For first term, that B part of the question. For first term, we have that using equation. Let's look for equation that is easier for us to apply. I guess equation 1 solve the problem. From 1, AR is equal to 20. So that means that for R equals 1 over 3, we're going to have this imply that A multiplied by 1 over 3 is equal to 20. So A over 3 is equal to 20. So A is equal to 60. Then for R equals 2 over 3. This implies that A will be equal to 20 times 3 divided by 2. That will give you 60 over 2, gives you 30. Therefore, A is equal to 30 or A is equal to 60. So that's where we're going to stop for problem number 5. So let's go to number 6. Number 6 is another interesting example. So how do you do that? I said that sum to infinity of a GP is 15. And the sum of the squares of the terms is 45. Find the first term and the common ratio. Solution. Let's say you have that the terms of the GP will be equal to A, AR squared, and so on. And the sum to infinity is equal to 15. And the sum of squares of the term, that means sum of squares of the terms, simply means imply that A squared plus AR all squared plus AR raised to the power of 2 all squared dots equal to 45. So this implies that A squared plus A squared R squared plus A raised to the power of 2 R raised to the power of 4 is equal to 45. That's the equation 1. And sum to infinity equals 15. S infinity equals 15. Imply that 15 will be equal to A over 1 minus R. We're looking at this problem. So, but these are summing to infinity here. From that equation 1, can simply see again that if you are summing to infinity again, that means that from 1 we are summing to infinity. At this point, A is equal to A squared and R is equal to R squared. That's a common ratio. So if you take sum to infinity, squaring it will be A squared all over 1 minus R squared. I say A all over 1 minus R. And this implies that 45 will be equal to A squared over 1 minus R squared. So if you are taking note of this, there are two things here. The other one is 15. You can as well divide. So let's say we have this to be equation 3. This is 2. This will be 3. So if you look at the 3, if you can divide it by substitute anyone that will prefer it. Let's see how division will take a look at. Dividing equation 2 as a dividing equation 3 by 2. That means 45 all over 15 will be equal to A squared over 1 minus R squared divided by A all over 1 minus R. This implies that 3 equal to a squared over 1 minus, consider this difference of 2 squared times 1 minus r all over a. This will cancel one of these. So this will be equal to a. A will cancel this one all over 1 plus r. So when you have this, you're going to have that 3 will be equal to a over 1 plus r. That's equation 4. Then from the same equation 1, we can take a look at something which is making subject formula. A is this. A is the right one. So A is equal to 3 bracket 1 plus r, and the A is equal to 15 bracket 1 minus r. If you equate the two, I mean that 3 bracket 1 plus r is equal to 15 bracket 1 minus r. This will cancel this to give you 5. And this will be equal to, let's complete it here. This implies that 1 plus r will be equal to 5 bracket 1 minus r. So 1 plus r is equal to 5 minus 5r. So we're going to have that 6r is equal to 4. So r will be equal to 4 over 6 gives you 2 over 3. So r is 2 over 3. So how do we get a? From equation 4. A is equal to 3 bracket 1 plus r. So A will be equal to 3 bracket 1 plus r, which is 2 over 3. This will be equal to 3 bracket 5 over 3. This is 5. So A is 5 and r is 2 over 3. So in conclusion, let me see if I can get it. Conclusion, A is equal to 5 and r is equal to 2 over 3. Thank you. Any question? Any clarification?